Alrighty, welcome everyone to the fifth protocol town hall, now being converted to the core devs call. So thank you for joining us. Just wanted to say a few words about this transition. So we noticed over the last few months, we see a lot of engagement from indexers, developers that are working, on GraphNode or, very closely to the protocol. And we're ready to create a more focused group around, core dev processes, doing a lot more ideation and building in public. And meanwhile, transitioning to a bit more of a community call cadence. So delegators, curators, subgraph developers can have their own forum for their own discussions and challenges. Would also like to welcome Streaming Fast to the core devs call and the graph community. This will be the first call they've joined. So excited to see what they come up with in their research and working with Edge and Node and other teams. Also would like to welcome Oliver Zerhusen, who has joined the foundation to work on governance. So you'll be seeing him around and a lot more frequently in the core dev and community calls. And lastly, wanted to welcome Semiotics. They'll be presenting a little later, but excited to have them lean in more with our community as well. With that, Ariel, do you want to take it away?
Yeah. Hello, nice to have you here for another core devs meeting. I will share my screen. I'm going to talk about protocol upgrades first. There are some changes in the staking contract and dispute manager that we talked in the previous core dev meeting. Those are related to having different slashing percentages on the dispute manager. We already talked about the reasons for having this GIP. But what I want to update is that these are already approved in the GGPs 3 and 4 by the council, and these are undergoing a vote in an on-chain vote, so the upgrade happens. Okay, so we already have 4 out of 6 votes, and it's probably will happen today, tomorrow, or the next day. So as a summary, dispute manager upgrade with the different slashing percentages, some staking upgrades with fixes, minor fixes about how reward snapshots are calculated and delegation parameters initialization, plus some reduced gas usage on the contracts by caching addresses. There's some delegation working group that is being organized by Oliver. He's collecting some feedback about the community from all the delegation feedback, so core devs can be connected and we work on we know the right focus to give it to the work, but he's going to talk more about that. So Oliver, if you want to take from here.
Yes, thank you, Ariel. Let me pull up my presentation. There you go. Can you all see the slideshow?
Yes.
Perfect. Okay, let me just tee up kind of like the history around what we are going to do. Already back in January, Brandon actually has consolidated some feedback that he's received at that point in time in 6 distinct sort of broader subjects that you can frame up that fall under the subject of delegator experience enhancements. So what we mean by that is parameters, it's processes all around delegations that really have come up as sort of either ideas or maybe current pain points that the community was raising as a sort of a forum item. Now, since January, we have in fact seen more items come through, and as a matter of fact, it's quite a bit. If you actually screen through the forum posts, you find probably about a couple of dozen different forum threads that touch on a number of different things, really in addition to what Brandon had collected. So, giving credit to Jim Cousins here, who a few weeks back has raised that as an issue that we have so many things out there and that we might have a need for, better consolidation of all the items that have since been raised so that we can actually put them all together and review and prioritize them and really come up with something that, as Ariel said, provides some guidance to the community as to how we want to prioritize it. So these are the items here that you're seeing, and we've really formed a cross-network group where we have Ariel's in there, Chris Wessels is in there from the indexer community. We also have Chris Ewing in there from the delegator community, providing us sort of guidance and feedback, from that end. And we are really calibrating on what are the most important issues to the delegators and how should we prioritize them. And we just coming out of a meeting last hour, had a very interesting discussion around sort of the dynamics, some of the constraints that we have within the network. So we're really having deep discussions so that we come up with solutions that are both meeting what the delegators want, but that also fit well within our protocol. The goal really is to present back to the community when we're done with our discussions a sort of roadmap around delegator process and parameter improvements. And that is something that we're going to have posted in the forum and that we're looking to get feedback on. In essence, what we want to come up with is guidance for the DevOps team, that they know out of the couple dozen forum threads that are out there, what should they be focusing on next as they do protocol enhancements. We also want to provide transparency to the community. There has been a lot of engagement around forum posts that delegators have raised, and all of that we are going to capture in here. And we also want to continue to get feedback, from delegators. So when you have seen the post being on the roadmap being posted in a couple of weeks, make sure you give us your feedback, how you think about it, whether you feel that we got it right or whether we're going to fine tune some of that. Now, Ariel has already worked on a GIP draft that already is essentially addressing some of the items that you've seen in the couple of slides ago. And this is something I really encourage everyone to go into the forum post. It's actually labeled under proposal to change indexer cut mechanism. It's a very interesting proposal that addresses a few pain points, that includes the transparency around understanding how indexers set their reward cut percentages. And it also makes it actually easier for indexers to maintain their cut percentages without having the need to readjust every time delegation amount changes. And it also actually addresses, one specific instance that we've seen coming up, which we call sandwich attack, where allocations can be, changed. I mean, the reward cuts can be changed, right before and after allocations that have, presented themselves as a pain point, and that is also a component that is being addressed. So make sure you get into the forum, provide your feedback there. We're currently fine-tuning that, Ariel is, and are looking to get a poll posted here fairly soon. And that was my update on that.
Thank you. I can take it from there. So based on what Oliver was saying about the proposal, this was an original proposal from Gary in the forum, and I took it and worked on a candidate implementation. I encourage any indexer or delegators to participate and add feedback and see everything makes sense and it's aligned with the solution for this. This is the current rewards distribution when you have indexers staking 30% of the stake and delegators 70%. Let's say we have 100 GRT rewards and the indexer cut is 10%. Indexers will get the 10% of the whole rewards and delegators the rest. So this is the way it works now. One potential issue with this is that even if you have a delegator with a small amount of delegation, this distribution is not taking into account the stake to the delegation stake to total stake. So it's not really it's not that the rewards are accruing for the amount of delegation. It's being distributed from the absolute amount of rewards. And the new calculation, this is the new calculation, I'm changing the slide. For the same stake, what it's going to do first is to assign rewards based on how much the indexers or delegators are staking. So the distribution of the 100 rewards will be dumped first on this ratio, and then the indexer will take 10% of the delegation part of rewards. Okay, so you will have a different share of rewards based on this new formula. It doesn't mean like the indexer needs to keep it to a 10%. Like it will need to adjust this 10% based on the yield they want to provide to delegators. In the forums, I posted like a GAP about this, and there's a link to a spreadsheet where you can see like how the delegator yield change and the indexer yield change based on different indexer to delegator ratios, and you can see basically this formula in movement based on change. So I encourage that you take a look at the spreadsheet and provide some feedback. The other thing is the current formula is working by using the indexer rewards cut when the allocation is closed. So it's not taking into account the indexer rewards cut when the allocation was created. So that means that the indexer has the opportunity to change the cut before the allocation is closed. Like can change it like multiple times based on that, and it's sort of I would say changing condition for delegators, and it's a bit of a speculation based on when you are closing the allocation. This candidate implementation had a change where we take a snapshot of the indexer cuts when the allocation is created, and that is used. So multiple different allocations can have a different indexer cut based on when it was created. Okay, and the reason for that is to avoid last minute condition change. So that's the other, I would say, main thing. So that's all about this upcoming candidate GIP. I encourage again, like you provide some feedback, and I'm going to talk now about like disputes. For arbitration, one thing that happened during the last 2 weeks was there were open disputes for P2P, one of the indexers that the core team analyzed and found out that were like determinism issues on the presented POIs. So these determinism issues were related to diversions on a particular block number by doing an if call that returned something different. So the resolution by the arbitration following the arbitration charter was to draw the disputes. So the funds were returned to the deposit were returned to the fisherman, and it was not slashed. Okay, so that's the main thing. As a next step, the team is going to is working on reproducing the wrong if call. Now the investigation is to find out was a particular condition on one of the Ethereum nodes or something else. So the current line of work is setting up a way so we can reproduce the determinism issue. Okay, and we will post in the forum more details about that. One more thing to mention about disputes is the team published this CLI that you can use and install easily on your terminal. It's a CLI that lets you manage all your disputes. You can like list open disputes. You can create indexing disputes. You can create query disputes by presenting an attestation. So this is like a first version. I think it will help a lot, and will be keep on improving and open for feedback. That's most of it. So Eva, who's next?
Awesome. I believe Adam is next.
Great. Hey everyone, I'm Adam. I'm product manager working at EdgeNode on the graph node. Let me find. Yes, I'm going to talk about two things today. Can you see my screen? Yeah. So firstly, it's about core processes. Let me actually just narrow so I can see anything. So obviously this is a very exciting time for the protocol in terms of the core development of the protocols. We've got more participants. So like as the network continues to roll out, we've got more and more indexes and so we've increasing an eye to that, but then we've also obviously got more core contributors. So like that includes streaming fast, but we've also got, for example, LimeChain working on a piece of work to support unit testing of essentially mappings. And so we've got more people participating, and so it's increasingly important to standardize and organize how we're sort of developing and releasing software. And obviously it's like a coordination challenge. So that everyone involved knows what to expect. Specifically here, like I guess like these are my areas of focus would be around sort of graph node, graph CLI, which obviously has index of CLI as part of it, graph TS, which obviously sort of supports graph CLI and sort of writing mappings. And then on the indexer side, there's the indexer service and indexer agent. Obviously those components all have different versions, and sometimes they need to move in lockstep, other times they wouldn't. But we want to like essentially try and standardize the way in which we're releasing, at least in particular when we're coordinating across core development teams. And so these are the core components. They're also these other two sort of important components of versioning. So the spec version, which is the version of the sort of the subgraph manifest, what that looks like, then the API version, which is the version of the mappings API. So and that's going to be particularly relevant, I guess, with an upcoming release, which I'll talk about in a second. And so essentially, I've just got a couple of updates and requests for people. So firstly, we really want to move to more frequent requests for graph node. We know there was quite a long delay between 0.22 and 0.23, and we want to try and move to a slightly more regular cadence. We're not going to commit to like a day and a week or of the month, but we want to move to, I guess, to every 2 to 4 weeks to try and essentially build that muscle and also get people across the ecosystem getting used to sort of upgrading on a regular basis. And I guess like as part of this, I've got a request for help. So firstly, need to find essentially more people to help beta test, so indexes for beta testing. So we've got a couple of people who we have been working with for the last release. We want to essentially move to doing that with more people, in particular if you've got software you write which is used by others. So we know that with the 0.23, there are quite a lot of migrations, quite a lot of changes. So if you maintain Grafana dashboards that are used by other people, then we want to sort of know that we don't want you to be taken by surprise. So please get in touch either in the forum on Discord. Then that'd be great. We also want to have more contributions to graph CLI from outside the core development teams, and so this comes back to the LimeChain assembly script work, unit testing work. So they're essentially creating a framework which we want to like ideally build in, and so we want this to be an ongoing thing where it happens more and more often, and so we want to essentially have a bit of a working group. So yeah, I think Petko is here, so he's it'd be great if you could be part of this. But if you're interested in being part of this and working how we could build more things into the CLI, then that'd be really great, and please get in touch. And then the last piece is, I guess, a call to subgraph developers. So upgrading assembly script to the latest version is something we're currently working on. All credit to Ottavio, who's been working on this, and this introduces new function, the sort of new latest version across Graph Node, Graph CLI, and Graph TS. And so we'll obviously, we're doing sort of thorough testing on this, but we obviously want to make sure that we understand all the changes, because there are some breaking changes in the essentially latest version of assembly script. So if you're interested in testing the latest version with us, then again, please get in touch. That would be great. So I'll pause there. That's obviously only sort of a light touch thing on releases, just in case there are any questions about any of that, or anything in general about like how we're managing things at the moment. Can't see, is there anything in the chat?
Nothing yet. I'll put a question out there just for discussion for these more frequent releases on the 2 to 4 week cadence. Do we have any thoughts on like whether those would be like minor versions, patches, major versions, and how are you thinking about that relative to the frequency of maybe upgrading the version at the protocol level?
For sure, good question. So I think, yeah, I guess an overarching thing is that GraphNode itself hasn't sort of had its sort of 1.0 version yet, and we're working our way towards that as I guess as a major version bump, and that'll be I guess a bit of a milestone because there's some talking about what we'll want to fit into that, but I think in general it will probably be sort of minor versions. So I guess like every couple of weeks, and I think that wouldn't necessarily I think we still need to work out how that fits into the protocol, because I think there's sometimes some reasons, and like at the moment that there's a push I guess to move to the latest version, so 2.3.1, essentially because it allows us to upgrade the IPFS node that everyone's using, because currently the 0.22 only supports sort of up to 0.4, so there's like a holistic benefit for the network to like if everyone upgrades, then actually we can bump that, and that then improves sort of peering and how, like the extent to which that node can fetch data, and people would actually start using their own IPFS nodes. So there'll be some instances where we'll, I guess, encourage like folks to upgrade, but I think in general it probably won't be every 2 to 4 weeks. But again, like there might be some instances where we've introduced new things, and again that comes down to the sort of the versioning strategy that I think we're still kind of working out, full disclosure, but I think that hopefully by releasing frequently we can again, as I say, build that muscle. Thanks.
On the question side, there's somebody asking about if there's breaking changes that comes up with assembly script update.
Where is that? Yes. So there'll be breaking changes, and essentially it'll be tied to the API version, which I mentioned. So this if I tried to reel them off now, I'd miss some. Essentially, it's going to be pretty well documented, and because it's tied to that API version, you'll be able to essentially use an older API, like the current API version, and that will all sort of work fine. And GraphNode will essentially support both in parallel for a while. And so, as someone says, that there's a detailed upgrade guide to help you all get through that.
Another question is, there are any plans to add more filters to block handlers?
Yes, so that's on. Yeah, that request certainly come through. I wouldn't say that there's specific time frame, but I think adding some more control in terms of block handlers and other filters has certainly come up quite a lot, and hopefully we'll be able to get to some of those kind of improvements. But yeah, I think one thing, slightly off topic, but we want to in general start to be a bit more open about what we're sort of working on, some of the like ongoing projects, and also things that we're sort of discovering. And so yeah, I guess watch this space on that on that front, particularly as we start to collaborate more with Streaming Fast and work out what we're all respectively working on. Cool. So then I guess just quickly, the other thing is this is more sort of building on sort of feature management. So this is one of those things that's leading into the GraphNode 1.0 release. Essentially, there's a GIP in Radical, which Brandon has been working on. I think I'll be iterating on a bit, but essentially this is providing a sort of formal pathway for introducing new features to the decentralized network, essentially from experimental through to full support. And there are a couple of ways in which we can do that. Essentially comes down to whether a given subgraph that uses a feature essentially will have query arbitration or indexing rewards and indexing arbitration. And there are some challenges to this. We don't necessarily track all the features that we'd want to essentially migrate in this way. So that's sort of up first. These levers aren't all tracked on the network. I think there is an indexing reward sort of flag which is set by the subgraph oracle. But then there's also like I think we need to establish like where the looks control is for like where an indexer would say that they do want to index these kind of subgraphs or make those kind of decisions. So be really interested to talk to indexers about how to best surface this configuration on the network. So yeah, I'll be reaching out obviously, but if you'd be interested to talk to me about that, then that would be great.
Awesome. If there's no more questions for Adam, then we can pass it off to Semiotics.
Okay, hi everyone. My name is Ahmet Özkan. I'm the co-founder and CEO of Semiotic AI. Semiotic AI is a Bay Area startup, and we are experts in AI and cryptography. And we are very happy to be part of the Graph community and grateful to the foundation for supporting our work. Our focus in the past several months has been query negotiations in the protocol, and the long-term success of the decentralized query marketplace depends on the economic efficiency of the market. For example, indexers need to optimize pricing and consumers need to bid efficiently to get the best service. And we've been investigating automating query negotiations with deep reinforcement learning. And towards that long-term goal, today, we would like to share some initial steps which have probably some more short-term impact to the protocol. And this is about, again, indexers' query price optimization, because this is an essential task. Some queries cost a lot more in terms of infrastructure costs, and latency can be used as a metric to measure this complexity. However, predicting latency given a GraphQL query is a very hard problem. And we started tackling this issue using AI, and I will let Matt to describe what we've been doing so far.
All right. Hey guys, my name's Matt Dybel. I am a developer at Semiotic AI. So as Ahmet was saying, we are currently trying to develop a method to predict the cost of running a query without actually running it. Which would be very useful in the everyday scenario you see here, where a dApp developer will send a query to the gateway along with a bid for how much he is willing to pay for it. The indexer is then tasked with pricing that query and figuring out how expensive it will be to run it. So currently this is done with Agora, which lets you lends you a lot of flexibility to specify how exactly you want to price a query. But it turns out that actually figuring out how to write simple rules to price queries does not quite catch all of these very expensive queries, which is a very hard problem, as was explored in this IBM Cloud Research paper that you see at the bottom here. So what we are doing is developing a deep learning model to predict the latency from a raw GraphQL query. So this is actually done in a few steps. First, we take the raw GraphQL query string, and we actually need to turn it into a more digestible form to the neural network. So we actually take each individual word and piece of syntax in the query, and we turn that into a categorical token. This gives it a better form that can then be fed into a deep learning model. Here we actually use a transformer model, which you may have recognized as being used with great success in things like GPT-3 and BERT. Here we just use the encoder portion of the transformer model to take in that tokenized query and output a final latency prediction. So we have applied this pipeline to a large amount of hosted data from the graph, and it has performed quite well within that data set. But there's a big limitation there where that data set actually contains a lot of repeated queries or very similar queries. So even though the model is performing quite well within that data set, we don't expect it to perform well on completely new queries that it would see in deployment. So to solve that, we actually moved on to solving query generation. Being able to generate queries comes with many advantages. Number one, we have unlimited data, which means that we can train the model until it is able to actually learn the syntactical qualities of GraphQL and actually predict the latency of completely new queries. There's also the added benefit of not needing any historical querying data at all. So one thing we could do is we could pre-train a model before a subgraph is even deployed. So before any queries are even indexed for a subgraph, we could actually already have a way to predict how much those queries would cost to run. We could also have indexers that could train models completely independently without any outside data set from the Graph's hosted service or even other indexers. So this is all great, but it comes with one very large challenge, and that's that generating queries is very hard. So the subset of random strings that actually form a valid query is extremely small. So what we have done is we have built a tool that can shrink this subset of this set of random strings down to the set of random queries. So what it does is it takes a partially finished query and it outputs all of the possible next tokens that are legally defined by the GraphQL syntax. And so we actually have a bit of a demo here for you. So at the top, you can see a query being randomly generated. And at the bottom, you can see the valid next tokens being generated by our tool. And right now, the generator is just randomly picking from that list, adding it to the query. And then the tool is looking at that partially finished query again and outputting all of the possible next tokens. So in the future, we can actually have a neural network picking from this list instead of randomly choosing from this list. And then we can do some other things, which I will get to on the next slide. So now that we have a query generator, we can actually plug it into our latency prediction training pipeline, which will look something like this. So now we will have a query generator generating a query. Our latency prediction model will predict the latency for that query. We will also feed that query through our local indexer to get the true latency. We can then compute the error between the latency prediction and the true latency, and then train our AI model as before using supervised learning. So the big thing that this solves over our previous training pipeline is that we now have unlimited data. So we have solved our data quantity issue, but we've actually introduced a new issue in that we now have a data quality issue. These random queries are by definition random, and they are unlikely to adequately represent the complexity that can happen in deployment. So our next steps are to actually introduce an adversarial component to this query generation pipeline. So this is the same exact graph you just saw with the added component of a reward arrow going from that supervised learning error to the query generator. So the query generator will be trained via reinforcement learning for making the cost prediction model mess up. So now it will be incentivized to come up with queries that are interesting, queries that the cost prediction model is not very good at predicting, so that now the cost prediction model can see those in training instead of in deployment, where it would be very bad if it messed up on them. So that is where we are headed, and we're very excited about the quality of model that this will be able to provide.
Awesome, Matt. Thank you so much for sharing. That was really insightful. Are there any other questions while we have the semiotic team here?
I can share some comments just on why I think this is super cool. So a common challenge that you see in a lot of blockchain protocols is figuring out how to cost different operations, usually compute and storage. And so the approach that you've seen taken almost every protocol to date has been to kind of set this at the protocol level, right? So you have like Ethereum, like gas costs, for storage, for different types of like opcodes for compute. And when we were designing the graph, we kind of came up with a similar came to a similar question, which was like, how do we price or how do we cost queries? And one of the challenges here is that configurations are so much more heterogeneous than you would see with like node operators running like a blockchain node, for example. You know, the cost of executing a query is, you know, very contingent on, you know, the caching that you've set up both in Graph Node, caching that happens in Postgres, the indexes that you've created, you know, how horizontally scaled your setup is. So there's really no way that we ever could have done like, you know, the equivalent of Ethereum gas costs, you know, as a protocol wide set of costs. And so instead we ended up with, you know, Agora, which, you know, Zach's presented in past calls, which gives indexers a way to flexibly communicate their own costs, you know, to consumers in more of a peer-to-peer fashion. But historically, it's been difficult for indexers to figure out how to set those Agora cost models, right? Like it's actually quite a bit of work to figure out, you know, what are my own costs, you know, that are idiosyncratic to my specific configuration, and actually how might I change that configuration in response to what those costs are, or in response to, you know, the market opportunity of the types of queries that are coming in, you know. And so this is kind of the first step in really making that a first-class experience, you know. So the tools that Semiotics and the models that Semiotics are learning is really making this kind of peer-to-peer pricing, price discovery, and like cost communication really efficient. And so, yeah, just the I think tip of the iceberg here, but a lot of exciting work to be done.
Yeah, we do have a couple of questions for Matt. You know, first one being a couple of people wondering, why didn't you use real data from the hosted service queries?
Yeah, absolutely. So yeah, perhaps I glossed over that a little too quickly, but we actually did first train on data from the hosted service. And the model performed quite well within that data set. But actually, when we look at the data, we find that a very large majority of the queries are actually extremely similar to one another because they're generated by scripts that are just sort of filling in variables or doing something similar. So even though the model is able to perform well within this small data set, it's not expected to actually perform well on completely new queries because the set of unique queries that the hosted service is getting is just a bit too small.
Gotcha. Next one is, what type of supervised learning are you using?
Yeah, so we're performing regression on the predicted output to the actual true latency. I guess specifically we're doing a mean squared error between the log of those two numbers.
Got it. So the next one is a longer one. What are the bottlenecks on the time it takes to compute a prediction? And what do we think a viable lower bound might be on that time?
Absolutely, yeah. So we've done, I think about a week ago, we did a sort of a study into that because that's obviously a very important thing. We need to be able to predict the query in less time than it takes to run the query. And so there's actually some great tools that exist for doing efficient neural network inference. And with those tools, we were able to get some of our models down to 200 to 500 microseconds, which is sufficiently low to be very useful for predicting these queries, since most of them take at least a millisecond or more.
Thanks. We got another one coming in. How long did it take to train the models in the most recent pipeline used for testing?
Yeah, so originally we were training on the full hosted data set that we got. And that took a very long time. We actually didn't even get through the whole data set. But as I said, we were actually training on lots of duplicates. So when we actually processed the data set further and deduplicated it, we got a data set of unique queries, and we were able to train on that in a few hours, I think. And that's including a few times through, actually. So yeah, it's a very small set of unique queries.
Thanks. I think that's all the questions we've had. You know, great job, Matt. Great presentation.
Awesome. Thanks.
Well, we have a few minutes left, about 15, which is abnormal for us. But if there's any questions around GIPs, upcoming protocol changes, maybe the arbitration charter, now would be a good time. Any comments or discussion items? Brandon, I saw you unmuted.
Yeah, I mean, just I guess generally, I would love to figure out a way to make these more interactive. You know, I love the presentation format for the, you know, for the start of it. But now that we do have multiple core dev teams, it would be great to discuss. You know, I know there's lots of other meetings happening, you know, where some of these ideas are being discussed, but it'd be great to, you know, even discuss some partly formed ideas on these calls. You know, to give people kind of a taste of work in progress. You know, one thing I think that came up in the index for office hours with streaming fast last week was discussions around like changes to the, you know, information model of subgraphs, you know, so the idea of actually breaking subgraph mappings into like multiple stages that that can be run concurrently, you know, for kind of optimizing performance. That's just an example, but yeah, it'd be great to give people like a view of work in progress, and even if something's not fully polished yet.
Alex, did you want to say a few words about that?
So I think, Brendan, you're talking about the parallelism, right? You want me to go through a little bit of that, the story, the pancake swap story? Is that the right place to do that? You know, some of the elements that we thought of, and we're writing an RFC on. That's what we're doing. Do you hear me well? Yeah.
Yeah. I think that sounds great.
So I did a demo to Chris from GraphOps. We had a lot of fun. So I've shown him the few lines. We added 6 lines to stage to transform the pancake swaps, which is a clone of Uniswap, basically, to stage it in different steps and to run all these steps in parallel. So that's one of the way we were able to chunk, like processing 1,000 blocks or 10,000 blocks and put that on 1,000 computers, and then have all of that run step 1 for the full history in 5 minutes, and then run step 2 in 8 minutes, because it does just a little bit more work. And then at the end, you know, we would have on disk files that have all of the values that you would eventually find in Postgres if you had processed the full history linearly, and the thing that was taking 2 months, right, linearly through mappings and querying. Yeah. So that's sort of a blend of the streaming fast technology, because it's based on files, opening files, processing data linearly in chunks, but the fact that you can parallelize that. And so that's what some of the thinking we want to bring there, or at least a proposition, or explaining our way of how we thought of it, how we implemented it, and see if that resonates, or if there's better ways maybe to do these things. So is that useful to all you guys? I don't know.
Yeah, that's super helpful. It looks like we're already getting some questions. One question I actually had during the last one was just what kind of files are you using? Are you using like Parquet files and like kind of column store layout?
So I don't know if this is right. Okay, so look, the streaming fast tech started from the principle that we want to take a blockchain and extract all of the data there is, so that we theoretically would be able to rebuild a node of the concerned blockchain, because we would have all the data, right? So all of the accounts and nonce change, all the state changes, all of the whatever you find in the storage of a blockchain, we want to extract and put into files so that we can process them. And files have great advantages as opposed to processes that are, for example, an Ethereum node, an archive node, right? There's CPU memory overhead, there's disk access, then you have large systems. I'm thinking of an archive node here, large, you know, disk needs to be managed. You want a copy of that to scale it out. You need to copy the big disk, run a lot of CPU and memory just to go access a little bit of the data. Whereas if you have things in files are the sort of the juicy things in data science, because they're eminently parallelizable, extremely scalable. Like things like S3 or Google storage is never a concern. And also cost-wise, if you have things in files, like in GCP, we're using that, there's not even a cost for downloading the file. There's not an egress cost. Everything is internal. So it's extremely cheap. And so when we're processing, I'm telling you, processing the full history of that section, I'll tell you that we processed the whole chain, all transactions unfiltered, right? And we did that 4 times. And it still took, like for that part, maybe 30 minutes, because that's negligible, right? When you're dealing with files, it unpacks very fast. So that's our core principle. We take the chains, extract the data, put them, we wanted to have the most complete description of all the protocols we handled. So we defined protobufs. That's what we're using. We wanted that to be easily consumed by a lot of different languages. So that's the first delineation of, I would say, a contract between data consumers and data producers. Any chain would produce protobufs in chunks of 100 blocks. These are stored into files. And then we have what we call the fire hose, which is being integrated by the team right now, that would bridge files and real-time streams. So the nodes, they produce those streaming blocks, and the fire hose knows to go to files, knows to now switch to the live stream, ensures contiguity, navigates forks for you. That's sort of the fusing of those things. And this is chain agnostic. And so where am I with the stage, with the, does that answer your question? I could go on, but.
Yeah, one follow-up to that. So it sounds like from the update at the beginning that you're kind of thinking about files all the way down. So files not only as the fire hose for the blockchain nodes themselves, but also these intermediate computations within GraphNode.
So what happens is that is for specifically the parallelized version, right? Of course, we for the Pancake swap store, we built the linear version that just goes linearly. This one already went faster because it was using files and the linear storage, not relying on hitting the node, right? Because there's a little bit more data in there. We tried to leverage it more and avoid hitting the node for information. So that's one thing. But so the parallel version, yes, runs the first stage and then drops the entities to disk. And then the second stage starts and picks back up the entities that would exist if it had run linearly. And that's why you can imagine you can't run a Uniswap without first knowing the pairs. So stage 1 goes and extracts the pairs for the full history, drops that on disk. The next stage starts with knowing the pairs. So it loads the pairs, and now it can do a little bit more work, computing whatever price average. And then you have another value that relies on the price average. So you flush the prices, first ones, and then you restart process, and you continue from the pairs plus the average on which you can build the next stage. Then you write a little bit more. And all these things produce very quickly. I'm thinking like maybe half an hour. So you have JSON files that are extremely easy to introspect, and you have full history. So for iterating, that's also one of the core principles. If you want data agility, the processes need to be extremely fast. That's why we always strive for parallelization. Because if you can't do that in blockchain world, you're just like, you're going to take more and more time ever. We can't do that, right? We'll have more computers, so we can spin up more computers, but we won't be able to extend the space-time to go more and more linearly. So that's why, in our opinion, parallelism is important, but it also gives you a lot of agility. So you can inspect the latest bits of the data before they're hitting Postgres. And that's the second stage in our operation. We took those files and then generated huge CSV imports, and we're using for the parallel injection, the fastest method there is to inject in Postgres, loading CSVs, removing indexes, and then adding indexes after, really to have an optimal ingestion. That takes how long? 3-4 hours with the rebuild of the index. So that's how we managed to shrink the full history in 6 hours. Is that interesting? Is that fun? So hopefully that answers your question.
Yeah, I think one thing that's really exciting to me about this kind of model that you guys are proposing is that it really maps a lot more to, I think, what a subgraph is doing, this kind of the pipeline nature of, the data. One of the features that, I know Adam's been thinking about a lot is like, what does it look like to have more, analytics style functionality as a first class, concept in subgraphs. And we were seeing this with, I believe the Uniswap subgraph, which Pancake swap initially, forked, which was that a lot of the overhead was actually within the mappings, them kind of, imperatively doing these sort of like aggregations and the types of things that really could be declared declaratively and be maybe staged as like a downstream part of the pipeline. But because we didn't give you that facility, it was like, okay, how do we put everything that we'll ever need inside this one mapping function that, runs, sort of sequentially. But, once we start breaking things out within the subgraph and these pipelines, it really starts opening up, possibilities for, for extending subgraph functionality, but also, on the performance side as well.
Yeah, and I think one of the interesting challenges there is that, like, I think at the moment writing subgraphs is like conceptually it just runs from top to bottom, and so it's a relatively simple mental model, whereas obviously this is making it much more powerful, much faster, and like it's definitely the way we want to go. But it's like thinking about how we surface that to subgraph developers in a way that like is easy to build the powerful subgraphs that they want to build. I think that's going to be like really interesting, like user experience challenge.
One question I have is just sort of an open question as this work is developing. It's just, what are the impacts on determinism from the file approach, and any impacts on like being able to bring along the proofs, the sort of provenance of the data along with, the data that's getting added to the files. So not just the raw data itself, but hey, the proof that this data came from, XYZ block.
I guess there's two aspects to that. There's okay, so that's in the work, the notion perhaps, or the proposition, we're going to write an RFC about that, to have sort of a network subgraph. That fire hose I'm talking about is raw data, unmishmashed. There's no mappings there. The blockchain produces a block, and there's data in there that should be deterministic in one way. And we've seen with the work in Aragon, they're trying to have another, sort of parity traces, and they figure out there's small inconsistencies between the implementation. So we've done a lot of work between different clients to output the same thing. So protobuf is the same, and the content there could eventually be sort of hashed, cross-verified in a way, and that could become, that's one of our thinking here, where we're thinking, we're going to write an RFC about that, have yet another service on the graph, perhaps, right? That would be would not, you don't query it, you don't, you shape it up to just to have, the information you want, but it's not, it's raw, unmapped. And then that could be used if it's composed by the other mappers. So you'd have, yes, provenance, maybe that it touches on a composability of graphs, and it starts making sense when you have a thing that is more raw and a thing that is less raw, because there's refinement. Eventually, I don't know if the composition between subgraphs and stuff could build into that. Brandon was talking about these things. Yeah, so that aspect, verifiability, that could be a service, and then yes, a subgraph building on such a fire hose could try to, and that thing is also very deterministic. Once the data is on disk and people are verified, there's just a lot less questions of the node had an issue. I hit a node was in the wrong place, or someone crippled the disk there, and I can't hash the SSD disk of the archive to know if the answer is going to be good. Yet whatever, like some things like that, right? Hitting network errors, we have that a lot. Hitting network error. Oh, I got a wrong error from the get token, whatever token name, so I removed it, and that was, we find like difficult determinism issue because you're relying on network systems. If it's just about the data and the data is complete, there's much less risk of determinism errors.
Right, it's a lot easier to compare files than it is to compare the sort of like runtime behavior of these different nodes.
Right.
Yeah, the network subgraph idea is really fascinating. There were some projects a few years ago that were kind of, I think after the graph came out, trying to apply the GraphQL concept to blockchain. I think ETHQL was one where they were kind of like thin wrappers around like JSON RPC,
right.
But they didn't fundamentally touch the underlying, semantics of querying that blockchain data, or the way that it was extracted from the chain. And so, I'm excited not only about the performance gains of exposing this through the graph, but actually providing potentially, maybe a more definitive or useful set of semantics on top of these networks that, might even get more usage than the sort of native, like JSON RPC style, APIs.
I think there's tremendous value in that layer layer because it empowers the rest, but also even for those communities, like if such a radical approach is brought to their chain, this brings a lot of value to their data, right? It's always been about valorizing or putting value to the data, making it valuable and useful. So
Cool, great discussion. Thanks for indulging me on that, Eva. I know we're at time. I'll kick it back to you.
Yeah, thank you so much. That was really insightful. And I am excited to have more of these kind of open forum discussions as we focus on core dev processes and more just core dev items. A few questions came through throughout the call on curation, delegation. We will be having community calls that Oliver and a few others are setting up. So that will be the best forum if you're looking to learn more about curation and subgraph development too. Thank you everyone for joining us for the 5th core dev call. See you next month.
Thanks, everyone.
thanks everyone.